You're on. All right, so this is just a overview of a relatively simple assembly problem, but using some angled mates, as well as the definition of a new coordinate system, and then measuring the center of mass of the part relative to that new coordinate system, as opposed to the global coordinate system, which is one of the things you should expect to see as part of the CSWP assembly problems, along with some of the advanced mates and like interference detection and stuff like that. So I'm gonna go ahead and hide my controls. I think I already downloaded the plane parts, but I'll check. Looks like I did not. So I'm gonna download the parts. I'm gonna open that up and I'm gonna put these into a new folder that I'll make on my desktop. No, maybe. There we go. It's important for me to make sure that I unpack these files before I start using them. If you try and open them from the zip file, it's going to give you errors. So just watch out for that. In SOLIDWORKS, I'm going to make an assembly. You can ask me what part I want to start off with. Most of the time, if you have a part named base or something like that, it's a pretty clear indication that that's the part you want to start with. On this one, it doesn't actually matter which part that I start with. Because I'm measuring things relative to the plane after I complete the assembly, but it still makes sense to probably bring in, put the base in, have that base be aligned with the assembly origin and have that be fixed, just so it's not trying to move around as I'm adding the additional components. And then in my diagrams here, I have the angles given to me in a specific order. So I have this 60 degrees, this 30 degrees, and this 20 degrees. So I'm going to try and put in and fully define each of these parts as I bring them in, just because I don't have to worry about them getting out of alignment as I move things around later on. So I'm going to bring in my other components, just so I have them all in here. And I'm going to move these to the side while I put in the parts that I want. So looks like this little arrow portion should come down here to the dial. I'm going to mate these together. They may or may not give you specific mates. Sometimes they just tell you how the pegs are aligned, or you can interpret it from the diagram. That looks fine there. Again, reasonably straightforward as to how that's supposed to be aligned. I've got a little north symbol on here, and it looks like this is supposed to be 60 degrees kind of off of that north inclination. So I need something else besides just the features on the part to do that. If I wanted to, I could use the faces on the parts kind of here and here to align that. But these look like they're going through the center of the parts. And so I probably have some reference planes that I can use to set up this mate. So that looks pretty good. That's probably one of them. And then I'll look through here. That looks pretty good. That's probably the other one. So I'm going to select both of those faces, click on mate, change it to angle, set it to 60. And now I got to figure out, okay, well, now I've got the right angle, but what's my alignment? So I'm just going to flip through these different options. That looks good, but it's in the wrong direction. That one looks appropriate. So I'll accept that. And then I like to exit the mate tool, come down here to my mates, click on the mate itself, and I should be able to see some of the dimensions associated with this. I may have to turn on some of my options here. There we go. So I'm going to double click on that. There's the angle. And you can see I have this 60. And I even have the purple and orange lines as indicated by that. If I go normal to this plane, I can probably even get the same orientation as given to me inside the sketch. So I don't have the plane there yet, so it looks a little bit different, but I can tell that I've got that aligned the way it's given to me in the drawing pretty confidently. And now that part is fully defined. So I don't have to worry about the orientation of that part for the remainder of this exercise. So I'm going to go down to the next constraint I have. I have a 30-degree angle here. Again, it looks like it's between the gray piece and the green piece. So we'll start off with just putting the dial on the indicator for that one, like we did with the first one. Going to mate the cylinders together, make them concentric. That looks good. I'll put the peg so it lines up flush with the end of the bar. Get it kind of close to where I want it to be. Something like that. And then I'm going to go again, I'm going to exit the mate tool, just as it makes it a little bit easier for me to see some of these indicators. Hide the base features, go to the yaw, which is this green part. Not really told which parts are which, but again, whichever it is. And I'm looking for the one that kind of lines up with a flat line there. We've got front, top, right, probably the right. Yeah, and actually let's go to normal to plane and make it a little bit easier to see. So I can see that right plane lines up with that orange line that's given inside the sketch there. So that one's probably one that I want. And then I want one that goes to the middle on this gray part. So I'm going to scroll down. That's the pitch part. Again, I can tell which parts are which because it gets highlighted when I hover over it. So there's the plane, there's the pitch. And I'm looking for that plane on this part that goes through that line. That one looks good right there. I'm going to click on those two. Going to mate them together. Specify an angle. Give it a value of 30 degrees. Flip it again. That looks good. Looks like that's what I have inside the drawing. So I'll accept that. Again, I'm just going to check it real quick. So same view, double clicking on the angle here. There's that 30 degrees. If it was over here on the other side, I'd be fine with that too. So if it was 30 degrees here, same angle, I wouldn't bother trying to flip it. But in this case, I have the same thing as given to me in the drawing. So that's nice. Last piece here, I have the plane itself. So I'm going to mate. I'm going to put the kind of tail of the plane onto the peg. Make sure it's aligned so it's going in kind of the correct direction. Oh, sorry, I hit the wrong button. So tail of the plane onto the peg. That's the wrong alignment, so I need to flip the alignment. That looks much better. And I probably want this to fully insert into the tail of the airplane. So I'm just going to make these two surfaces here align. That looks pretty good. And I can see I have, again, another dial reader kind of on here. And this last image looks like we got a 20-degree kind of tilt. I'm going to assume this is coming at it from the front, just because it looks like it is based off the indicators on the rest of the part. And again, I've got these in the position that they were given to me. So if I get the right view, it should look the same. This one looks like the part has been made transparent. So I'm going to change the transparency of the plane. And then I'm going to go normal to this face to get something close to that. That doesn't look quite right. Let's see here, the pitch. Let's go normal to the front plane on that. Oh, no, that's the wrong one. Sorry, this is the pitch down here. Let's go normal to that plane. That looks pretty good, except for it's upside down. What's the hotkey? I think Alt. If I do Alt and then hold on the middle mouse button, I can flip that. But I think that's probably the closest I can get the orientation I'm given inside that plane. That looks pretty good. This one, it looks like we've got like the tail of the plane being used to do the alignment. And I could use that one, although since I've been using planes for all the rest of them, I kind of feel like I should keep doing that. There, I've got a vertical plane on the pitch part, a vertical reference plane. And then I also, let's see here, we have a plane, there we go. We have a right plane on the plane. So a right reference plane on the part, on the airplane. Those two look pretty close to what I have in the diagram here. If I can't see this good, I would open it in a new tab. Look at the part. You can always zoom in on this and get a better idea of what you're looking at. But I'm pretty sure I want that one to be 20 degrees. So let's go to the angle, set 20. It's obviously not the right alignment. Flip the direction. So again, making sure you're going in the right direction on all these. It's pretty easy to get one of these flipped. Click OK. And again, if I want to see that angle again, I can double click on the angle mate, kind of show it and confirm that it does look like it's supposed to look. And it does. And the last thing I need to do is need to add a coordinate system. On this one, I would probably just add it in the part because it makes it a little bit easier for me. So if I open the part, I'm going to go into my references here. So I'll go over references, plane, axis, coordinate system. I've got the coordinate system of the plane, it's already on the origin, but if I want to be explicit, I can specify that. It says the x-axis is supposed to be forward, the y-axis is supposed to be to the right, and the z-axis is downward. So currently this is not the correct orientation of the coordinate frame. The x is going to the left, so I want x to go forward. So I'm going to look for my front plane. Now my x is going forward, so that's good. I want my z to go down, so I'll look at my top plane. I'll flip that. And because I need to specify something else for my y-axis, so I'll use the right plane. And then I can't flip both of these, but I can flip one of them, so I'll flip that one. So now I've got x going forward, z going down, z is the blue one, and then y going to the right on the plane. And again, it's easier for me to do this on the plane part because I don't have to worry about what the rest of the kind of coordinates are doing. So I'll click accept that. And maybe rename this. So plane system, just to be clear. If you name all of them coordinate system 1, it may be a little bit hard to keep track of which ones are which. I don't know why it doesn't change the handle on here, but whatever, you can always click it from here. So I'll save that part. And then I can go back into my assembly. And I should be able to see my coordinate systems. So there's my new coordinate system for the plane. And I want to measure the mass properties relative to that coordinate system. So I come to mass properties, get a little drop down option here. Using the plane system, I can use my plane system. Maybe I have to make a coordinate system in my assembly. That's just a copy of that one. I could have made this coordinate system in the assembly as well. I'm not sure why SOLIDWORKS cares. Let's make a reference coordinate system that is based off of the plane coordinate system. Yeah, I want to use the same orientation as well, though. I could go through and just copy it again, I guess. Front. Y is my right. Z is my top. And I gotta flip that one and that one. Like it shouldn't have made me do that. I should have been able to get the coordinate system from the drop down here. I do want it for the full assembly. Maybe an option that I have somewhere in this system. But anyways, I got my coordinate system and I got the center of mass in the Z direction, which is 10.9. And we're in millimeters. So it should be good. I'll paste that in, submit. And I actually got it right. Yeah, got it right. So questions on that?
Can you go over again how you did the coordinate system?
Yeah, so whenever you want to define a coordinate system inside a part or an assembly, you're going to use the references. So in this case, in the assembly options, I have assembly references or assembly features. Sorry, assembly references. Here it is, reference geometry. And then there's a coordinate system option. The coordinate system is going to require an origin location, so a point. And I can use any point that I want. So say the edge of that face right there. And then either planes or lines for the directions of the axes. So I can use a line. And you see now that my x-axis, the red one, is aligned with the line that I just picked. Or I can use a plane. So if I go to the y-axis, I can do normal to that plane. So you can see the green, the y-axis is now going kind of down on this system right now. And that's actually enough to define the coordinate system. I don't need to do another one. But if you want to specify a third direction, you can. Just gotta make sure that it's not like conflicting with the first two. So in this case, my Z is going kind of to the left. If I wanted to pick another line here, I could do that and then it adds that other reference to it. And then we can flip two of these to get all the possible orientations. It doesn't let me flip the first one because it has to follow the right-hand rule. So it has to be a right-hand rule coordinate system. It won't let me say like, I can't say I have a right positive X and then a left positive forward and then a Z positive down. It has to go kind of right to left and then up. Does that
Thank
make
you.
sense? Does that answer your question, Marza?
Yes.
And then you can always choose not to see those coordinate systems if you don't want to see them. And if you had another question that asked you to do something else with this, probably this kind of assembly, the only other thing that I would expect them to try and ask might be looking for interference detection. So if I suppress this angle here, now I can rotate the plane. So I can look to see if there's any spots where the plane kind of hits or any part of the components collide with each other. It doesn't look like this one will. I could cheat and make it hit though. So here, so let's go plane. We'll change my boss extrude here. And I'll make it longer. We didn't like that, did it? Did it actually get longer? Or did it just like compress my loss? Just compress my loss. Do this. I don't hate that geometry, but I do want it to be a longer part, so that way it'll interfere. There we go. So if I wanted to know like when this plane was going to collide with that part down here, I could go into my options under evaluate, look for interference detection, and then I'm sorry, I want to move and look for in the move options. I want to look for collision detection. So I'm going to go to assembly, move components, turn on collision detection, stop at the collision. If I want to, I can make a sound that doesn't really matter. And then I could rotate this part until it hits. And now I've like collided these parts. And if I don't move anything from here, a lot of times they'll ask you to kind of give you a mass properties when the parts collide together or something like that. You gotta be a little bit careful with those because you got to make sure you have all the other parts kind of defined fully. So if this part were still free to rotate and I were to move to a collision point, that might not be the same collision point as if I were to have it fixed at a specific angle. So just make sure you're following the instructions for all those assemblies as closely as you can. Other questions?
Should the y-axis be coming out? What do you mean by the going to the right?
So on the plane, the plane kind of has a nominal orientation. There's a forwards, a backwards, a right, a left, a top, a bottom. So I mean to the right relative to the plane's direct coordinate system. So if I look at this plane from this perspective, I have kind of forward end of the plane and the tail end of the plane. If this is the front and this is the back, then this is the right and this is the left.
Yeah.
So in this case, the y-axis is pointing to the right on the plane. And there's probably a better nautical term for that. So if I use like, port or something, I don't remember which one's port or starboard. I don't remember which one's left or right. But I figured that would be more confusing than left and right. So I'd prefer to use language that is less ambiguous.
Okay.
Anyone else have any questions or concerns? I'm going to stop recording.